If you recall earlier in the class, we talked about how it could be a good idea to write out geometry at various steps throughout our setup. In this video, I'd like to go a little bit more into depth about that, and we're going to actually make a SOP level OTL that will handle reading and writing geometry for us. Now, before we dive in, I have made the last 3 OTLs in the setup, and I'd just like to very quickly point out that they're really just display them in turn. I really just copied those parts of the setup and then created an OTL and promoted parameters. So they're really not that complicated. So I don't want to spend too much time on them because I think we've already covered all of the principles that are required to create them. So instead, we're going to go and do something new, which is make a SOP level OTL. And we're also going to talk a little bit more about how to integrate Python with our OTLs. So let's get started. Now with an OTL like this, that's a very generic type thing, I don't really need to create it in the context of my setup. Instead, I might just create a geometry node over here somewhere, or more likely in production, I would make a whole new HIP file. But for now, I'm just going to create a geometry node here. And we're going to call it geometry IO testing. And we're just going to do it with a very simple case so that we don't have to worry about anything getting complicated from our setup. So I'm just going to make a sphere. And I'm going to put a very simple animation on it, like a sine wave. Something like this. I'll just home the viewport so that we can see that our sphere just kind of wobbles back and forth because of the sine wave. And we are ready to get started. Just like at object level, we're going to be starting with a subnet. So I'll go ahead and make that. And let's just go ahead and create the OTL right away. So right click, create digital asset. And I'll just give it the exact same naming convention we're used to. I'm going to call it geometry_IO or input output. 2 colons and a version number. And then we'll just go ahead and change the label. And as usual, I will just save it someplace that makes sense. All right, and let's get started. Now, right off the bat, I'm just going to go ahead and dismiss the type properties dialog, delete this instance, and put down another one. And that's just so that I can test the nice naming convention stuff that we made before. And it looks like it's working here in SOPs as well, which is pretty cool. Let's just bring type properties back up. We're going to say maximum outputs is 1. And now that we're at object level, I'd like to actually use the minimum inputs field as well. And all this means is that we require at least 1 input. And in fact, we have to have the single input that we have filled in. And if I hit apply, it's unlock and save. And let's just put the display flag and then take this off. You can see that it errors because I don't have an input here. If we middle click on it, we can see it says not enough sources specified, which is the error that we get when we require an input but don't have one. I'm going to go ahead and wire it up to my sphere. And the idea of this OTL is going to be that we are going to write out whatever comes into the input, and we'll also just read it back in again. So those 2 operations will be stuck into one node. The other reason to make an OTL out of this instead of just putting a file SOP and a geometry output SOP is that it would be nice if we could standardize where we're actually writing to and automatically create any intermediary directories that might be missing. So we're going to go ahead and do that. Now, another thing that we haven't quite looked at yet is custom icons. A cool thing about the way that Houdini handles icons is that you can see that it says SOP_subnet here. you can actually just give it a context here and then the name of any node type, and it will automatically find the icon for it to put into our OTL. So for example, we could just say sop_file, and you can see the little button here change to a file sop icon. And if I hit apply, now my OTL looks like a file sop, which is pretty nice. And of course, we can easily tell that it's not actually a file sop because of the color and the naming convention that we set up. Let's just name our inputs and outputs. We'll call this geo to write out, and the output will be geometry from disk. Hit apply, and we can see our nice labels. All right. So now let's just go ahead and start putting nodes inside. So I'm going to dive inside. And I'm just going to put a ROP geometry output here. Wire it into the first input so that we can write out our geometry if we want to. We're going to leave the output file alone for now because we're going to be generating that with a Python function. I'm just going to name the node write, and then make a file sop, and I'm just going to name it read. And let's just go ahead and do an output node. Now, as far as parameters to promote, I would like to have the save to disk button, but we're actually going to do something special with that, so let's just leave it alone for now. Instead, I'll just promote the reload geometry button because that's one that we just want to have use default behavior. As far as the interface goes, we're also going to be creating some nice interface for generating paths. The first thing that we need is a name. So I'm going to give it a string parameter. And this is just going to be a sort of a base name for whatever element I'm generating. So it could be something like fire or rocks or tentacle lines or something like that. And then we're going to be generating the path based on this element name. So I'm going to call this name, give it name as a label. And of course it has no default, so that's good. And then I'm just going to also do a version parameter. And for versions, we're going to do a range, and we're going to say that the user is not allowed to use versions less than 1. So we're actually going to lock that part of the range. So if I just go ahead and hit apply for now, and come back up here to look at my interface. This is not bad, it's a little ugly. I think these buttons are not related to this naming kind of parameters, so we're going to just create a separator there. That's a little bit better. And the last thing that I want to do before we dig into the actual Python parts is I want to promote the frame range parameters. And I'm just going to go ahead and drag those in as well. So let's just dive inside, go to the right node, and let's just go ahead and drag them up. And I'm going to add another separator just to keep things nice and clean. Hit apply. And something that you'll notice is that even though it's set to render current frame, the disable when string for the frame range itself got removed when we promoted. So let's just go ahead and add that in again really quickly. And if you aren't familiar with the syntax in this, you just surround everything with curly braces always. And then you just give it the name of a parameter, in this case, tRange. And tRange should be off. And we can tell that it should be the string off by just going to the tRange parameter, going to the menu tab and looking at what the token is, which is off. All right, so now that we have all of that set up, I'm just going to switch it to render frame range. And let's start figuring out how to generate our path. Now I am going to quickly just put a name like Blorg, just so that we are going to get some kind of valid path straight away, because I don't want to bother going in and doing path validation. All right, so how do we add Python scripts to our OTLs? Well, we already know that we can make uncreated scripts by going to the scripts tab and creating an event handler for uncreated. We can also create a Python module. And in this Python module, we can add functions that we can then call from other places in Houdini, including from the interface. So I'm just going to define a function, let's say def output path. And for now, let's just not make it take any arguments. And I'm just going to print who.pwd. And this is sort of like the first way that people ever think to define functions in the Python module for OTLs. They think, oh, I'll just use who.pwd, and then it will give me the node that I'm on right now. Unfortunately, it doesn't quite work that way, and I'll show how that happens in a minute. All right, so let's just go ahead and hit apply really quickly. And let's look at how we can call this function from other places in Houdini. And then once we do that, we'll just go ahead and make our button. So I'm just going to hit Alt-Shift-P to bring up my Python shell here. So the way that we can get access to the module for an OTL's definition is by using a function called HDA module, which we can get off of the node object in Python. So I'm just going to drag my main node object in here, and I'm going to go ahead and assign it to a variable called n, just so that we can see what's on n. And we have this HDA module function, which just gives us this module. So then if we want to access this function, we can just say dot output path. And of course, there needs to be a underscore there. And you can see that who.pwd here did not return the node that the function is on. And the reason why that happens is because who.pwd stands for print working directory. And basically, that just means wherever you're calling the function from, that's what pwd is going to be set to. So since we're in our Python shell here, we are calling the function from Houdini thinks it's just from slash. Another interesting thing about this is that this module exists on a per definition basis, which kind of makes sense if you think about it, because it's just living here on the type properties dialog. It's not in any kind of node instance specific sort of dialog. So that means that if you define a variable in here outside of one of the functions, like a equals 10, for example, a is going to be 10 no matter where you call the function from. So you could have dozens of instances of this node and then say, hey, Houdini and HDA module, what's a? Of course, I didn't hit apply. What's a? It's 10. It's always going to be 10, which means that you can actually share data between instances of OTLs in that way. We're not going to be doing that in this class because we don't really have a reason to, but it can be useful in some rare circumstances. And it can also come back to bite you if you aren't aware of it. So I'm just going to go ahead and delete the variable here, and let's make this output path function actually work. The first thing we need to do is get the actual node. And the way that we do that is by just passing the node in as an argument. So now if I print node and hit apply, and of course this is kind of stupidly simple. And now I do in dot, you know what, HDA module is a bit annoying and long to type. So fortunately Houdini does provide an HM shortcut, which is just going to give you the same result. It's also a function, so we'll just call it and we'll say output path. And then we'll just pass n in as the argument. And we can see that we now have our nice instance here. So that means that whenever we call this function, we're going to have to know what node we want to give it in order to generate the output path. All right, so let's just have our output path function generate a real output path. And we're going to run through this pretty quickly because the Python code is fairly standard Python if you're familiar with the language. So the first thing I'm going to do, because we're going to use it, is just import OS at the top. And remember that this HDA module is not dependent on any single instance of our OTL. So that means that OS is only going to get imported once, and we're not going to be running this code over and over and over again as we instantiate the OTL over and over and over again. All right, so the first thing I want to do is get the directory. So I'm going to say directory, and what we're going to do is just make everything relative to our HIP file just to make things nice and simple. And that'll mean that we can copy our HIP file around and go ahead and hit save to disk, and it'll just work, which will be pretty nice. So I'm just going to say, actually call this HIP directory, and we're going to say os.path.dirname who.hipfile.path. And that'll just give us the directory that contains our HIP file. So now that we have that, I'm just going to generate an element name. So we're going to start by making a template. So I'm going to say template. In fact, let's just call it element template equals. And since this is a template, I like to put names in the format strings. So I'm going to say name underscore v for version. And then we're going to say just version. And then we can use this nice syntax here. I'll just finish off the string really fast. We can use this nice syntax here to tell it to pad by 3 zeros. So instead of being v1, it'll be v001, which is kind of nice to look at on disk. And then let's just go ahead and make the element name like this. Say element template dot format. And since there's a few different things that we're listing, I'm just going to say name equals node.eval_parm name. And then we're just going to say version equals node.eval_parm version. And that gives us the name of the element. Then I'm just going to make a list of everything that I've made now, and then I'm going to join them together using a string join operation. So we can just make a list by saying path tokens equals, I'm just going to do a multi-line list so that everything's easy to read. The first token will be our HIP directory. The second one will be something like geo. Then we'll have a directory called element, a directory using our element name. And then I'm just going to create a file path by saying something like element name .bgo.sc .format element name equals element name. And basically this is just going to say my file is going to be this element name that we generated here, .bgo.sc. Now we do need to actually have a frame number in here, so let's not forget that. So we'll say element name .frame.bgo.sc. So we'll just go to the end here and say frame equal who.frame. Now let's just go ahead and return our full path. So return /.join path tokens and hit apply. Now you might be wondering why I didn't use os.path.join to use whatever the correct backslash or slash is. And that would be slightly more correct. It's just that who.hipfile.path returns things with slashes always, even though I'm on Windows. So I kind of just want the whole thing to be slashes. So because Houdini is kind of weird, I'm going to be weird like Houdini, and I'm just going to follow Houdini's lead here. And honestly, Houdini doesn't really care whether we use slashes or backslashes, so it's fine the way it is. So now that we have a function that generates our path, let's just see how it works by diving inside our node and using it on our write node and our read node. So we're going to switch the default language of our node to Python so that we can create a Python expression. This is a string parameter. So we're going to alt-click to create a keyframe, and that'll allow us to add Python code to this string parameter. I'm going to click into the parameter and hit Alt-E to bring up the expression editor. And then all we're going to do is just say parent equal node dot slash dot, or just a single dot dot. I'm used to the object level OTLs. And that'll give us our OTL. And then we can just say return parent.hm dot output path. And then we pass in parent as an argument, which, if you remember, is just our argument here. So now if I hit apply, and in fact, I'll just hit accept to dismiss. Let's just see what we got. All right, so my path isn't exactly what I want. There's two problems. The first one is that my frame number is actually coming in as a float. So I'm getting 1.0 here, which isn't really that useful unless I'm doing subframes, which I'm not in this case. So let's just go ahead and convert who.frame to an int. And hit apply. And that gets rid of the 1.0. And the other thing is, I don't really want this to be counting up from 1. I'd rather use the padded 0 type thing that we used with the versions, so that we get 0001, for example. So I'm just going to go over here to my frame, and I'm going to add, Fiduni wouldn't be annoying. I'm going to add the same funky syntax that we used for the version, just so that I get 0001. And we can see as we increment our frames, our frame number does increment here. And now all that's left is, I'm going to just right-click and copy parameter on this one. Go to my read node, right-click, paste expressions onto the geometry file so that it will read the same thing that it's writing. And then let's just make sure that the version parameter works as well. So we're set to version 1 right now. Let's just set it to like version 6. Looks like it is in fact working. All right, but we still don't actually create the directories. And in order to create the directories when we save, we'll need to make a save button. And in order to have a save button, we're going to need to have a save function here for it to call. So let's just go ahead and make the save function here in the Python module, and then I'll show you how to call it from the button. So we'll do def save to disk. Again, we're just going to give it a node to pass in. And then we're going to say something like get the output path first. So output path. And in fact, I can't use that because that's the name of my function. So let's just call it outpath, output path node. And that'll give me our nice output path. I'll just say out directory equals os.path.dirname out path. And then we'll just say os.makeDirs out directory. Now, note that the ROP output driver does have an option for creating intermediate directories automatically, but we're going to want to just put something that does the same thing into our Python module, because a lot of facilities have some kind of custom function that will deal with things like naming conventions in the directory structure and stuff like that, and they actually require that you use those instead of whatever Houdini does by default. So while we're going to be doing the same thing by hand that our ROP output driver could just do on its own, we're going to be handling that ourselves just to simulate what it's like to actually work in a production environment. And then all that's left is to actually save to disk. And we can do that by saying node.node, write, getting our write node, and then I'm just gonna do this. And then calling the callback script on this button, which is called execute. So we'll say write.parm execute.press button and hit apply. Now if I come back out, of course we need to run the function from a button, which is our next step. So let's just go ahead and do that really fast. We'll go to parameters, make another button, and I'm just going to horizontally join it to the reload button so that we create a nice little button strip here at the top. So it looks a little bit nicer. I'll just call it save to disk and same label. So now that we have our save to disk button, we need to actually have it call our function from our HDA module when we click on it. And the way we can do that is with this callback script. Now, since we are going to be calling a Python script, we do want to make sure that our callback script's language is set to Python, which I have it set to Python already, but you'll probably be set to HScript by default. So just make sure that you're switched to Python. Now, the way that we can call things from here is exactly the same as we did from our Python expression and from our Python shell. Now, fortunately, since we are going to be using pwd here, because we're not going to be calling this from anywhere else, it's only going to be called from inside this button. Houdini provides us with another shortcut so that we can have shorter expressions in here. And that is who.phm. Sorry, phm. And that's just who.pwd.hda module. It's just a shortcut for the same code. And then we're going to say .save to disk. And I'm just going to give it who.pwd as the argument, which is the node. So if I hit apply, let's just try it out and see if the button works. Save to disk. Seems to have done something. It removed the error, so I'm going to just dismiss the dialog. And yes, it does seem like we are looking at an animated sphere. And if we dive inside, of course, we are looking at the output of the file, so that means that we're reading from on disk. And now, whenever we want to write something out or read it and then read it back in, we do not have to worry about whether or not the directory exists. Now, note that I'm not showing anywhere on the interface where it's writing the geometry out to. I think people tend to have kind of philosophical differences about whether or not it's a good idea to show that. There is a school of thought that says that artists and users should not really care where the geometry is going or getting read from as long as they know what version it is and what the name of it is. There's another school of thought that says that some people do actually want to manage their geometry on disk. And honestly, I can see wisdom on both sides. So for the purposes of this class, because it's simpler, we're just going to omit that parameter for now and just control it by changing the name and the version. All right, so now that we have version 6, let's just make a version 1 as well. So I'm going to go to version 1 and hit save to disk. And yes, we get our nice sphere. And in fact, for version 1, I'm going to just change the animation slightly. Say plus 90. And save to disk. And this is something where it doesn't want to save over the directory that already exists. I could just put a check in there and say, well, don't try to run the os.makeDirs function if it already exists. But I kind of like the idea that we can't save over versions that have already been written. And we'll just keep versioning up. The problem is that that traceback is kind of hard to read. So let's just make a better error dialog. So I'm going to go back to my scripts tab, and I'm going to say if os.path.exists out directory. So my directory that I'm going to be making already exists. We're going to say who.ui.display message path already exists. Please version up. And then we'll just do \n to go to a new line. And then put a format marker, say .format out directory. And then we'll just return just so that the rest of the function isn't run. So now if we hit apply and I try to overwrite my version 1, it's going to give me a more friendly error message. Okay. So let's just write a version 2 with our new animation on it. All right, so now I have a slightly different animation. And what if I'm working on version 2 and I have the version 6 and I know I have the version 6? And it'd be really nice to be able to just compare the two. What I'd like to do is add a diff2 version feature to this OTL. So we're going to do that by going back to type properties, going to the parameters tab, and we're just going to add some new version params. The first thing we want is a toggle, and I'm just going to put a separator here so that it's clear that it's a new section. And we're going to just call that enable diff. And I'm going to make the label diff2 because I'm going to horizontally join to another version parameter that isn't going to have a label. So it's going to be like, this is the label for the version parameter. It's just a little bit prettier that way. And then I'm going to put an integer here and say diff version. And as I said before, we're going to remove the label, go back to our toggle, and say horizontally join to next parameter. If we hit apply, we get something like this. And in fact, I'm going to say diff2 version so that it's clear what that means. Then under my diff version parameter, I'm just going to do the same range adjustments that I did with the main version parameter. So we're going to say range lock to version 1. So that way the user can never go down below version 1. We'll hit apply. And then one last thing I want to do is do a disable when string for my version. So I'm going to say for you, we're going to say when diff to version is turned off, we're disabled. So we'll just do our curly braces here. We'll say enable diff equal 0. And hit apply. And that way, when I turn it on, it's enabled. When I turn it off, it's not. So let's just turn it on for now so that we can work with it. And I'm going to set the version that it's diffing to version 6. Let's dismiss this dialog for now. We'll bring it back up in a minute. I'm just going to go in and add my diffing nodes. So we're going to do another file swap, and we're going to call this one diff. And let's just make our switch that says, are we diffing or not? So we're going to say switch enable diff. And we'll just say that if the checkbox is 0, it sends it to this null that's called oblivion. And we'll just wire it in. Input 0 is the null, input 1 is the file swap. And then I'm just going to put another null that says guide geo out. So what is guide geo, you might ask? Well, if I just go ahead and hook up my switch really fast, let's say ch enable diff, so that you can see that this file swap has a box. If we come back out so that the output node is displayed, in fact, just to make it less confusing, I'll just put the display flag back over here. Just remember that this guide geo out is showing a box that comes from this file swap. So our main display flag is set on the geometry that we're reading back in, and in this case, that's a sphere. But what we can do is Houdini allows us to say, well, this is the geometry that we're working on, but it's useful to be able to compare it to another set of geometry. So we want to display that other set of geometry in wireframe. Now this is very similar to the way that a template flag works. So like if I had a box here and we turn on the template flag, we can see it in wireframe over here. But the problem is that when we're working with OTLs, if our geometry that we want to compare to is actually inside the OTL, we can't really use template flags in that situation. Fortunately, Houdini allows us, back inside the type properties dialog, Houdini allows us to specify what's called guide geometry, which is pretty much just template geometry that is always set for an OTL. So let's go to our node tab. We can just set it here in the guide geometry field. Let's do that, and we'll specify guide geo out and hit apply, and actually hit accept to get rid of it. All right, and we can see our guide geometry here. And if I hit W, you can see that it's the file default geometry. All right, now obviously we don't want it to be just showing a box. We want to show it version 6. And therein lies a problem. We want to get our same path here, but it needs to be version 6 instead of version 2. In other words, it needs to get its version from this parameter and not this parameter. There's a couple of different ways that we could handle this, but if we go back to our type properties dialog and go to scripts, we are going to need to tell our output path to allow us to somehow tell it what kind of version to take. So the approach that I'm going to take is to just say version parm name. And because we've already used this in a bunch of places, let's say that we're in a production environment and we've decided to add this feature, and we realize that this function is being used in a bunch of different places, and maybe it's non-trivial to change all of them. So instead of just forcing everyone to update all of their code, what we can do is just say version parm name equals none, and then provide a default. So currently, the way the function works is it's just hard-coded to always use version. So I'm just going to say if version parm name is none, version parm name equals version. And that way, if any code that already exists calls this function the old way, it's going to just change it to what the behavior was before, which is to read the parm called version. So now I can just say node.eval_parm version parm name. And if I hit apply, it looks like we didn't break our old code. And we can just say copy parameter off of our old read sop. Go over here to our diff node here and paste expressions. And then we can just say when we call the output path function, version parm name is going to be diff version. All right, so let's see if that worked. If we click here, it is indeed reading version 6. So let's just dismiss the dialog, come back out to look at our nice OTL. I'm going to go ahead and save and match, just so that just because our OTL is finished. And zoom out a bit and just hit play. And we can see that we can compare the geometry that we're currently reading and writing to some other geometry version. And if we don't want to read two versions of our geometry off of disk, which might be quite heavy, we can just turn off diff, and the guide geometry disappears, and our OTL should run much faster. In this video, we looked at how to create a SOP level OTL that writes out geometry and reads it back in, and we added a few features that make quality of life for artists a little bit easier. In future videos, we'll continue looking at how to improve our technical setup.